Good morning to all. And as you all are aware that BIM, Building Information Modeling, is a very highly efficient and emerging technology and is becoming really essential to ensure the planning, design and construction of buildings. So this webinar, the objective of this webinar is to make students aware of the basics and practical applications of this technology in real-time designing and development. And we are really thankful to Mr. Vinayak Mathur, who is the BIM manager at Pinnacle Infotech, who is here with us as the technical expert for today's session under the Industry Institute Interaction activity at Poornima Group. We welcome you, Vinayak sir. And I would like to introduce Vinayak sir to the students. Mr. Vinayak is a mechanical engineer with over 3 years of BIM experience at Pinnacle Infotech and over 1 year of manufacturing experience at Robert Bosch. He loves to work in a multicultural environment as he believes that they bring an element of diversity and developing problem-solving methods. Also, he enjoys working in a team that looks at the same challenge at multiple angles. So we are really privileged here to welcome you, sir, and I would request you to take over the session.
Right. Thank you, ma'am, and extend my good morning to all the attendees. And I would like to begin this session with, so this session is, well, it's an overview of the industry about what BIM is, Building Information Modeling, what it is, and how it benefits the industry and how it came to be in existence, basically. So more than 2 decades ago, we had just begun with the integration of IT, the integration of computers in the field of construction. Earlier, how it used to be, it was that we would be having the architects, we'd be having all the stakeholders like the architects, we'd be having the civil engineers, we would be having the trade persons, namely the mechanical guys, the electrical, the plumbing systems, the people who would be handling the firefighting services for a building. And how it would be was that these guys would be working independently and they would be preparing their engineering drawings, their construction installation drawings, based on which they would have to install their services or construct the whole building altogether. So how it used to be was that the whole building would start off on a piece of paper. We would start off with drafting those service lines, and we would design, and all the design work and all the drafting work would happen independently and within the closed departments. And there wouldn't be so much communication. If I just take an example of, let's say I have a class of some 20-30 students, and what I do is, okay, 5 or 6 of you guys, we'll form a team of 5 or 6 people. One team is going to be the civil engineers, one team is going to be the mechanical engineers, one team is going to be of electrical engineers, then they will be having the plumbing systems team, will be having someone who will be looking into firefighting. And I would assign them a task that, okay, we have to make this building, and this building has a so-and-so deadline. We'll have to begin construction by this time. And until then, we'll have time to design all the services. We'll have to design, based on, if for the civil engineers, the architects, they'll have to look into the facade. They'll have to look into the load-bearing calculations. For the mechanical engineers, they'll have to look into the HVAC, the whole HVAC. They'll have to look into the load calculations. They'll have to look into the flow rates, their technical data, their technical stuff. And the electrical guys will have to look into their technical trades, and they'll start designing. They'll start preparing a draft of how the services, but what I mean here is the ducting that you see, the pipes that you see in a building, or the electrical cable work that you see in a building. So we refer to them as services. So how these services are going to be routed out, and how their layout is going to be spread out across the building. We'll be having the civil engineers working on their load calculations. So these teams, earlier back in the old days, there wasn't so much of communication. So one team, the mechanical guys, will prepare a routing of their ducts, and at the same time we'll be having the fire protection guys working on their routing, their firefighting pipes and systems. And they would all come together towards the time when we would begin the construction process. And then at that time, they would encounter a problem. This problem would be mainly of conflicts. These conflicts would be between the services. Now, the mechanical guys, they had little to no communication with the other guys. Like they had little communication with the electrical team, they had little communication with the civil engineers, and likewise. So how it would be was that at the end of their design phase, when they would actually begin work on the site, they would encounter a lot of problems that, there would be clashes between the ducts running through the pipes. And, these conflicts would create a lot of arguments between the team. There would be, there'll be a loss of time and money, and the whole schedule of the construction would be impacted. So later, as time progressed, we began the integration of computer-aided designing and drafting in the field of construction. So all these drawings that the people were drawing manually through hand, it was a really time-taking process. So now people started working on computers. Now the computer would prepare these drawings much quicker than how it would be hand-drawn. But yeah, the problem of communication wasn't really resolved here. So now we would again have a team of people who would be having these conflict issues that their services cannot be installed because they have issues with so and so other team. So these problems later led to an identification of a need to clear this communication issues. So how BIM came to be was that it is basically an example of IT integration into the field of construction industry. What we're doing here is, you could say, we make a building twice through BIM. Once it gets done in a computer, and second time it gets done in the real world, the real physical world. So I'd like to start with why BIM. So as it says here in the underlying text, that we begin with the end in mind. Now what we're doing through BIM is that if I take another class of students and I make the same number of teams, have the same amount of team members, they may even be of the same competent level. Now I'll allow them to communicate with each other. I will allow them to work on one single dashboard, and everybody can see the progress of what the other guys are doing. And at the same time, as time progresses, the mechanical guys can see what the electrical guys are doing. And if the mechanical guys have any issues with how the electrical guys are laying out their services or how their plans are going, if they see that their plans could impact the mechanical guys, or let's say the civil engineers have issues with the mechanical trades, then this information can be passed on to the concerned party within the right amount of time. So the right amount of information gets passed on to the right person, it gets passed on in the right amount of time. So what this brings to us is we have sufficient time for action. Now, these problems that these guys will encounter when they're working on a dashboard, working together, right now the construction on site hasn't started. So what these guys are doing, they're just working on one common dashboard. You could say like they're working on one computer. So we'll be able to identify these problems before they occur in the real world on site. On site, like I said earlier, that these guys would be having conflicts, they would be losing time, we would be losing money. So all these things, they wouldn't come into play in the picture at all then. All this would be resolved beforehand inside the computer itself. So what the computer is doing here, what this whole BIM is doing here, is that it's simulating the real world of how things could be in the future if we proceed with how we are about to proceed right now. And this will just allow you to take certain countermeasures to tackle those challenges that we could face later on site. So the slide says that we inhabit a three-dimensional data-rich world. So the picture that we see here is the routing of, we see routing of multiple services. By services, I mean we have the pipes going here across the floor. We'll be having the ducts in blue. We'll be having these services which will be spread out across the floor plan. We'll be having the ducts. We'll be having the red pipes. These are the firefighting systems. We'll be having we'll be having some mechanical equipments that are placed inside a particular room, or if it's a server room, it'll be servers. If it's a mechanical room, you'll be having boilers and pumps. So the whole building is actually simulated in a computer. It's completely built in a computer. And what we're simulating here is we're testing it that everything is perfect. Everything is is not going to clash with anything. We are having everything designed to meet its requirements on field to the end customer, the one who will be utilizing the building services. And BIM doesn't just end here. We're not just simulating a building and constructing it, and then we just close the whole aspect of BIM right there. BIM now extends to much further possibilities. New frontiers have come up as time progressed with BIM, because people began to realize the potential of having this simulation done beforehand, before the construction begins on site. So now not only were we saving time and money on site, we are now also able to give in information related to procurement as to how much material has been used to create this building and how much it's going to cost. If I make certain changes, how much those changes are going to cost, and things like that. So I'll get to those points later on. There'll be a slide that'll cover those information. And so it says that why not design and construct based on the final conditions? So since we'd be having all the concerned stakeholders, or you could say the concerned parties involved in the project from the very beginning, we'd be having them while we are running the whole simulation. We can get the input of every concerned party in the right span of time. So we'll be able to identify problems, we'll be able to know the possibilities, we'll be able to know certain conditions that the client may have, or certain requirements, specific requirements that the client may have later. And we'll be able to cater to those requirements right now itself. This way, as I said earlier, that we'll be able to save a lot of time and money. So this slide just covers the benefits of the BIM process. And if I were to put it into more general terms, just think about the benefits that you get when you work in a team, when there's teamwork involved. So when you're working with BIM, we'd be having the guys who are modeling, or who are drafting the services, who are laying them out across the floor plan. We'll be able to do that comparatively quicker than how it was in the very conventional ways. And we'd also be saving up on the time and the quality of the job, since we'll be doing it in less number of times. We won't be having so much rework, because a lot of people are involved in this. A lot of people, meaning collaboration, and coordination. So since more people will be involved in this team, we won't have to rework so many times. We won't have to do those discussions so many times that I'll have to change my own work multiple times just so I can accommodate to your needs. This way, we'll be saving up a lot of time. And the third point here is conflict detection and risk mitigation. So when we have multiple people working together in the same model, we are modeling and creating all these pipes and ducts, and the whole building is basically being generated in 3D. You can identify the areas where we are going to have clashes between things, where we are going to have pipes running through the ducts. And when you come across a clash, that this is not how it's going to be on site. So you will have to take steps to remove those clashes. You'll have to remove those conflicts, and as you remove those conflicts, you will be removing the risk that people on site could face. So this is one advantage of how a simulation, having something done in a simulation first, helps out to the guys on site. Now the fourth point here is high level of customization and flexibility. Since we are working in a computer, and we are having all this being simulated, and we also have the owner, the guy who's putting in the money, who's creating whose dream it is to have this building built for him. He's also involved in this process. He gets the information, and he also has, let's say if he has certain customizations in mind, that guys, I think we had this space towards the northeast corner of a building. I want it to be changed. I want it to be, utilized in some other way. Now, had this communication not existed before, what would have happened was that the engineers and everybody would have built something on the northeast side, and then the owner would get to know about it, or he would find out about this midway through the process, and then there would be those changes, which would be, and it would be really hard to turn the direction of the project and adapt to the new needs of the customer. So now what BIM allows us here is that since it's a simulation, nothing has really begun on site. We can have n number of customizations. We can have a lot of changes built into our model, and then we can also have those changes tested for feasibility if it's going to work out or not. So this is one advantage and one major advantage that I feel for the BIM process in the field of construction. And another point is the factor of time and money. So these are really key items that one needs to keep in mind when you're working on any project. Even if you guys are working on your major project or minor project in the final year, you must be having this cost benefit analysis or in a basic project schedule that this is going to be the timeline of my project and this is going to be the cost of the overall expenditure, or let's say this is a particular zone in a building and this is how much it's going to cost. So time and money, it's very important to keep track of these things when you're working on projects, be it a small project or a large or any kind of building you're working with. So this is easily enabled through BIM. And as I said earlier that the building, we're not just using BIM to just to construct the building and leave it there and leave the systems right as they are and just close down on the whole simulation. We are now using it for facility management. Facility management would be when you construct the building, have it all set up and hand it over to the owner. Now comes the part where you're running the building, the running costs come into play and the whole maintenance aspect comes into play here. So BIM is now also able to provide you services for maintenance. And earlier, we would just have these things modeled in a system and checked for clashes, and we would remove those clashes, have things constructed, and things would eventually there wasn't much that we could do. But as time progressed, now what we're able to do is we are able to provide very real data information about the services that we have installed, the mechanical equipments that we have placed inside the building. For example, you could be having a boiler of an exact manufacturer, and you could be having the information about the power capacity. You could be having the information about the temperatures that the boiler would offer. You would be having information about the power rating of an HVAC unit. You would be having information about the discharge of a particular pump that has been placed inside your building. So it's like you're in a model, a simulation, wherever, and you have all these elements around you, and you just click on one item and you can get all kinds of information of that item right in front of your eyes and in a second. So you can have information like manufacturer, you can have information like the maintenance cost, you can have information about what is the next service date due. So all these details regarding running a building or that deals with the operation cost of a building comes into the maintenance and facility management. So that is also one application of BIM. So BIM has gone all the way up to there now. So as I said in the beginning of the PPT, I started with the story that earlier we just had drawings to work with. We didn't have anything in 3D. We did not exactly have something visualized, where we just had a plain imagination and a 2D paper helping us to install these things on site. Now, here's a drawing of how clustered or how dense something can be in a complex area in a building. So we could be having multiple services running around, and the engineers would also have a tough time reading such kind of drawings, and they would have to carefully analyze every service and ensure that nothing comes into physical contact or nothing clashes with anything else. And also sometimes you would end up if you just follow these drawings, you would end up sometimes spending in a non-economic manner on the services or on your applications in comparison to how you could optimize these things in BIM. So for example, you had a pipe that was running from in certain twists and turns, but later you realize on site that you have spent extra material running a pipe through around corners. Well, it could have been done, it could have gone in a straight line. So you could have saved a lot of time to install that pipe that way, and you could have also saved some money. So all these things, they couldn't identify certain issues beforehand, before installing. And it would only be until the guy would appear on site and begin placing these services in the ceiling space, at that time they would realize that, okay, now we're having conflicts, and that conflict, okay, I'll have to talk with the mechanical team, I'll have to talk with the civil engineer about this, and then the discussions would go on, and it would take a long time to actually build that area. So one problem here was that things weren't really visualized in a three-dimensional space. What we had was 2D, X and Y. But what we have achieved with BIM is, and through the softwares that have helped achieve this state, is that we are now able to convert everything into a three-dimensional space. So now we can identify whether certain things are going, whether they're clashing with each other, or they're going over or under, or if things need to be dealt with in a more economic manner, a routing can be changed. So as the slide says, that the building services will be coordinated to a level suitable to verify that the locations of building services, plant and distribution are feasible for contractor and subcontractor installation without major rerouting. What this means is, I can run this simulation inside a computer, and I can check, if all this routing is done in an economic manner. I can check whether this is a practical way to really install these services. I can see if it's going to be time saving, if it's going to be cost saving, and bring this simulation as close as possible to the real world. So the closer your simulation is to the real world, the quicker it's going to be installed, and the less amount of conflicts your teams are going to encounter. So this is what BIM does for the construction industry. So BIM is a socio-technical system that comprises of three elements: people, process, and technology. This could be, just like we have for a manufacturing plant, we have any policy, any process, or anything that has been incorporated, or a process that is followed in a manufacturing plant has to do with either man, machine, material, or method. And these four things are basically governing all the principles that we follow and through how we manufacture. And it's always revolving about these four people. Similarly, for BIM, it's the people for whom this whole tool has been created. It's the process, a process that could be a set of protocols, a set of standardized instructions that everybody agrees upon and follows together and achieves their common goal together. And the third is technology. The technology is the enabler here. The technology is what is enabling the people to achieve their goals here. And when they all work in amalgamation, when they all work together, that is how you achieve success, how you achieve your goal of having a building constructed and delivered to the facility management teams, and to deliver to the owner in the least amount of time, in the most cost-effective manner, and in a manner where the owner will find it really easy to run this building through their maintenance process and so on. So the people aspect. In the people aspect, we have the top-down approach, where we'll be having, when a building begins, we'll be having the owner, we'll be having a lot of stakeholders. We'll be getting to a slide. I could just take it there. Okay, so here we have the owner, we'll be having the engineers, we'll be having the architects, we'll be having the steel team, we'll be having the building management systems team. So what we see here is basically the concerned stakeholders who will be working together in this simulation world, and they'll be preparing this model, the BIM model, based on which the installations are going to be done on site. So these teams, as this slide indicates, they'll be working in close communication. As you can see here, BIM basically unites all these stakeholders together. We'll be having engineers who can directly communicate with firefighting team. We'll be having the firefighting team who can communicate with the steel guys. They can communicate with the architect. The MEP trade can communicate with the facade or the engineers. And these teams can communicate amongst each other. So conflicts, they can be resolved easily, and they won't be able to develop to such an intense level that it would take a lot of time, or it would take a lot of money on site to resolve them. This way, you can just eliminate any possible issues that you could have on site. If you have all the stakeholders, all the concerned parties talking to each other much before the whole construction process actually begins. So here we have the top-down approach, which, as I demonstrated to the previous slide, we'll be having multiple trades working together, and we'll be having, let's say, a general contractor who will be having multiple mechanical, electrical, and plumbing or firefighting trades working with him. And these trades they might be able to, let's say, if they could be outsourcing their job, they would have more subcontractors working with them. So there's a whole hierarchy of how the project is being run, basically. And every team is going to have one, or at least they'll be comprising of a separate team of BIM champions. These BIM champions are the ones who will be leading, or who would be part of the leading team for execution and implementation of BIM for this particular project. These guys would be in touch with the people who would be responsible for installation of all these services on site. They would also be in touch with the guys who would be working in the simulation world. Now, these BIM champions would also be responsible for ensuring that a communications is established and it stays strong between the guys who are working for installation of these services on site, for actually bringing these out in the physical world, and with the guys who are working in the simulation, who are trying to ensure that everything is being done in the most economic and practical way. So let's say that the people who have worked on the simulation model, and they have done their best on how things could be the most practical, or how it may seem most practical to them. Now they will share this information with the people who are working on site, or who have the experience of working on site. So these guys can then offer their input on how things can be installed according to their ideas. So the people on site can give in some input to the people who are working in the simulation model, that guys, I think you have laid out these services correctly, and I'm not able to, I don't think there are any clashes between them, but we can take so-and-so procedure to have this services routed this way, so it becomes easier for me to install. So this way, everybody gets to have their say in how the whole project execution is going to be. So it's like everybody gets to agree on something, and the project direction, it stays stable. So the BIM champions will also be looking forward to training more people, identifying more training needs for a better execution of BIM, and they would be identifying people who would be working on the simulation world, and they would also have a steep learning curve. Basically, it'll be a learning experience for anybody who works with this technology, since it's an ever-evolving one. And the last 2 points basically communicate that it's frequent and meaningful communication, and environment must be collaborative, not combative. So since you have a lot of people working together, there'll be the element of collaboration, and communication is going to be strong. Everybody is going to listen to everyone, and everybody gets to have their say, basically. And nobody gets to experience that moment, that I wasn't informed of this change, and I only got to know it at the last moment. Everybody is in it since the beginning. So this is the one advantage of what a collaborative and a communicative environment offers. Then we have the process. The process will be like, it'll be a general set of protocols, it'll be standards, there'll be instructions that have been standardized, or you could say they have been agreed upon by the entire stakeholders team. And these processes have been developed keeping in mind what is easy for the whole stakeholders team to achieve their targets, to achieve their objectives of having an easy installation, an economic one, and a time-saving one, and also while keeping in mind the owner's requirements. So around all these points, or around these all objectives, we stitch up a process that we need to follow for the BIM execution. Then comes the technology. The technology is the enabler here. So the technology would just be covering parts like, okay, we have to achieve a certain objective by the client, and what kind of facilities need to be provided to the people aspect so that they can work upon the client's needs and have the objectives met. Now that can be, let's say it can be a need of hardware. You'd be having workstations to work on powerful systems that can cater to the software's needs. The software would be as per the requirements of the client, and what kind of software we're looking to use, that would be a decision taken up by the execution team. Then we'd be having the specific, let's say, project requirements of the client of, or if a client wants something to be done in a certain way, and what kind of facilitators can adapt to that particular way which the client is asking us to follow. For example, if the client has asked for, let's say I want absolutely real world data from the very beginning itself. So I'd be taking up a software that can offer real world data from the very beginning itself. Or if the client wants, okay, I just want a basic representation of things. I'm just doing a feasibility check. I'm not really constructing my building. I just want to know how much it could cost. Then I would be using a slightly different software. So softwares would vary as per the client's requirements. And so would the hardware eventually, if you're using a different kind of software. Okay, so this slide we have discussed already. It just focuses on the concerned stakeholders in a BIM project and how they work together to ensure that everything stays transparent in the whole communication world, and everybody is aware of all changes, and everybody gets to have their say, and within the right amount of time. So this slide that says that BIM is a database. So imagine if you're painting let's say a masterpiece on canvas, and you've you've painted the landscape, and you've painted the grass and the trees. You've given them certain shades of green, and the whole sky is blue, and the birds in the air. Now, towards completion of your painting, and you have this thought that, what if I want to change the color of the grass that has already been painted, or of the birds that have already been drawn into the canvas. So now, as a painter, his hands are tied. He just has the palette in his one hand, and he can't really change the color of every single element that's already been drawn in. Now, if I would bring in this perspective, that the BIM is a database, for example, if this painter has the option to just tap on that particular color and select a different color, and the entire grass would change, and all the colors of the birds, their feathers would change, or the color of the sky would change right on. Just by changing the color of a small element, the whole change gets reflected in the painting. So this was, earlier it was not possible when BIM did not exist. All we had was, somebody who had manually done in the input work, and things would be slightly different on site, or, we would be asked to change something from the very initial phase, and the whole process would go back to its initial phase, back to square one. And then we would have to do another feasibility check. Okay, this is how this new change is going to look like, how much it's going to cost. And, it would be a long time taking process. Now, what BIM allows us to do is, for example, I have created a simulation of a building wherein I have placed multiple air conditioners of, let's say, Daikin. And, as I have progressed through the project, later on, I get to receive this information from the client that, we won't be installing the air conditioners from Daikin. We would be having Hitachi's air conditioners. So can you tell me how much it's going to cost? And can you tell me what change it's going to make in the overall HVAC network? Now, BIM allows us to, what it allows us to do here is that I just have to change a group of units concerned, a set of air conditioners from Daikin to Hitachi, and I could have this impact observed from the entire model, across the entire model. I'll just change one thing, and it would basically lead to change from the next process flow, and that would change another process flow, and the eventual result would also change. I can have that in a very short span of time. So this allows us to basically run any kind of tests related to time and money, and basically any kind of thing that the customer wants to run a test on. If he wants to, let's say I want to run a test on, if I shift this mechanical room from this particular area from north zone to the south zone, what it's going to impact me, how much it's going to cost me, is it feasible to construct? So all kinds of feasibility issues that the concerned stakeholders may face, can be very easily tackled through BIM. And since you're working in a simulation world, it'll be very easy to simulate and check and re-simulate and recheck until you come to a decision that you unanimously decide that, okay, this is the best possible approach that we can take. So one difference between a BIM software and an object-based one is that, we had AutoCAD in third year or third or second year, where, we were just drafting on the basis of a certain drawing that would be given to us in college. So we would just prepare a column, or, we could prepare an object, a three-dimensional, a cube that would basically be a set of lines. And that's what it actually remains. It just remains as a set of lines in AutoCAD or in a typical CAD software. But in a BIM software, you model it in a three-dimensional space, and it remains as an object. It doesn't stay as a group of lines. So, with that object, you can associate certain information. For example, let's say through solid modeling, I have modeled an air conditioning unit. Now, if that had been done in AutoCAD, it would just remain as an air conditioning unit, and you would only get the visual sense of it. You would not be getting any inherent information that can be linked to that particular model. So through BIM, what I can do is I can model this air conditioning unit, and I can type in those details, the very specific details like the manufacturer, the price, the servicing cost, the servicing duration, and any other concerned required parameters, and I can associate that information with that object. So now what I have in my hand is that I have an object that I can place in a simulated model, and I can place it in n number of places, and all these parameters can be fed in. So this information would eventually help the client identify these things in a much more easier fashion. What I would have is, like, for example, after the building is constructed and I just hand over the model to the client can just walk around the simulated model, and he could just, click the air conditioner, and he could get the price of it. So for him, he wouldn't have to run through any paperwork. He wouldn't have to run through the drawings. He wouldn't have to run through any cost estimate sheets to figure out how much that air conditioner had costed him, or if he wants it repaired. So it'll be very easy for him to manage the whole facility management process if if he uses BIM. So he just has to open one model, and he just have to click around certain elements to get their information. So it'll be much more time saving, and it'll definitely be cost saving for him as well. Now, another thing that BIM enables us is work sharing. So if you go back to this slide, what we have here are the stakeholders who are working together in a particular project, and that is being facilitated by the BIM technology. Now, what we are doing here is we have multiple people who are working together, but they're working on the same exact file. They're working on the same environment. Everybody sees the same duct, everybody sees the same building, and any change that the engineer makes will directly be visible to the MEP guy, or any change that the HVAC person makes will be visible to the firefighting person. So since we are all working together, we are working on one file. We don't have work split up and all the communication is terminated among teams. We don't have work split among the teams. The teams are working in one environment and they're working together. So this slide basically just further stresses on it that we'll be having a central file on which all the parties work, and every party will be having a local file visible to him only. And he will be making any changes to his local file, which would then be impacted or reflected on the central file. And these changes would be then visible to this person, and he can have his changes made accordingly. And these changes would be visible to the first person himself, as well as everybody else in the team. So this slide basically stresses on the applications of BIM. As I said earlier, that what the people would do in the past was that they would create these drawings that were not exactly coordinated. They were not so much in touch with the other teams. The mechanical guys were not so much in touch with the structure. They were not so much in touch with the electrical and firefighting teams. So they would have their drawings, and then when they would actually get to installing those drawings on site, they would be having conflicts. Now, these drawings, you could say they were not so accurate. or they were not so reliable. So now what BIM has done is that it has offered a 3D simulation environment where you can have these services tested. And now when you have tested your services, you have run through the simulation, you have removed any clashes and conflicts. Now you can again prepare those drawings. And now those drawings are more reliable. They're more accurate. So this has been possible. These accurate drawing sheets has been possible through coordination, which was in fact possible because of visualization that was facilitated, that was provided to us, and collaboration that was again provided to us through the BIM technology. So that's just the surface. That's just what we see on the surface here. If you go underwater here for the iceberg, now it doesn't just end there. Now we have analysis work that we can do. Now, okay, let's say we have simulated all these ducts and pipes inside a building. We have placed all those centrifugal pumps. We have checked in, okay, that how much discharge these pumps can offer. I can do some analysis. I can run another technical simulation as to check whether the sizes of the pipe running across the building are good enough, or let's say they're validated, that they can function well with the pump that is providing the discharge. Basically, everything is technically feasible and physically applicable here. Likewise, I can check, the flow rates. I can check the loss of head that I could have by running certain fittings in a certain manner. I can identify all these technical aspects, which could eventually impact the people on site. I can have that tested, and I can have those changes made within the simulation world itself. I can have the sizes of the ducts and the pipes tested. I can have those changed if I want through the simulation process. So what the simulation through these analysis process, what this is offering me is, it's a validation of the model, that okay, the model has been created, it is economic, it's time saving, everything. But is it really achieving the objective of the building or the objective of the client? And is it doing that in the most cost effective, time saving manner? That all this can be tested through analysis. And these calculations would later come into the picture, as through the analysis you'll be having these calculations run by the software itself, testing the duct size and the pipe sizes and the flow rates, and it would be giving you a report as to what flow rate you're going to get at the end of the room in a corridor, and if is it the required amount of flow rate that you require, or does it need to be changed, or duct sizes need to be changed. So all this analysis can be facilitated by the BIM software. Then comes the part where we have 4D and 5D and 6D. So 4D would stand for the time aspect. The first 3Ds would be the X, Y, and Z. I mean, having everything visualized and simulated. The fourth D would be the time aspect, which would be, okay, now I'm having this building set up, and I want to know how much time it's going to take to construct this, or I want to keep in track of my schedule, the construction schedule, that with the current pace of what the team is working at, how much can we achieve in so and so time. So that can be provided to us through 4D. Now you have the information about how much time it's going to take to construct this. Then you have the aspect of 5D cost analysis. 5D brings into the picture the money aspect. Now I have built all this, how much it's going to cost me in so and so amount of time. So this is what the 5D is going to offer. The 6D is going to offer facilities management, which is going to be, okay, now I'm about to hand over this building to the owner. What all information I need to keep track of, or what all information I need to feed into the model, that it can be helpful to the owner even after the whole construction process is complete and the owner is just running the building now. So new frontiers are being shown up here as this technology is evolving with time. And these are just some of the aspects to the extent of which BIM has evolved to now. Okay, so I'll just be going through this particular slide in a brief manner. So this is the BIM project execution plan. Is just some basic points about, you have this technology available to you. How you execute it is dependent on what the requirements are. And along with that, there are certain standard procedures that every execution plan would usually have. Now, every execution plan, irrespective of if it's a BIM project execution plan, or if you're working on a fabrication project for in the automotive industry or anything, you'd be having a goal, you'd be having the objective as to what you want to achieve. This objective is provided to us by the client, the end user, and it gets passed on to all the stakeholders who are concerned. Likewise, you'd be having, okay, this is the objective. Who is authorized to work in this model? Who is authorized to, who is going to be helping us out here? Who are going to be the stakeholders? And we'd be having information shared to us, like the project information, where this particular project is situated at, what's the site information, what the survey says, what is the sea level elevation, things like that, and who are the general contractors, who are the all the concerned party members. Then we have the key project phases and milestones. This would basically be a reflection of the project timeline. Let's say we are working on a 10-floor building, and by what time or by what year or month, we expect to complete up to the first 3 levels and the next 3 levels. We could set milestones in this whole project timeline to ensure that the planning is done in a more stronger fashion. It's done more thoroughly. Then we have the roles and responsibilities. So now since we have identified what we have to achieve, who is going to work, now we have to also identify who is going to do what, and all the stakeholders, what their responsibilities and job roles are. We'll have to develop collaboration strategies. We'll have to develop the technical infrastructure. Would just basically be the part where we have to ensure that all the stakeholders have the hardware and software required to achieve the objective. The collaboration strategy would be how we are going to meet, how we're going to have these meetings done. We could be how we are going to share our issues with the team. Are they going to be through, let's say we can have them through email. We can also have them through the actual BIM environment, where every clash can be identified and observed by every single stakeholder, and everybody can have their input on it. And since you're working on a large project, you'll be having lots and lots of drawings to work with and work on. You'd be developing naming standards and naming conventions as to, okay, let's say the HVAC drawings are going to be named as HVAC hyphen level 1 and so zone, and the whole naming structure would be dependent on the overall standards being followed in the project. The level of development matrix, this basically is about, let's say, I think a lot of us have played computer games. So whenever you go to a game settings, you'd be having this option as to, where you will switch on or off the shadows. Do you want to keep the textures in high detail or low detail? So when you're visualizing something, having it done in a computer world, you'll have to fix upon the level of details or the level of information that is being provided in the visual sense. And that is one reflection of the level of development that I could say, that you're simulating an environment, but to what detail you want to simulate that environment. Do you want the manufacturer's name, or do you don't want those manufacturer's names? Do you want that exact space that an object is going to occupy? Do you want the exact shape and form and texture of that object that you're going to model, or will a basic box-like representation work? So all this, it's completely dependent on the budget of the project and how the owner wants it to be. So all these things are, they're only allowing us to be flexible and cater to the changing needs of the customer here. So this is one aspect called modularization. So this is one thing that I'm working on right now as well. So we're working on this hospital project in the United States in Phoenix. So what we're doing for the client here right now is that we have all these items created in a 3-dimensional model. And now, the real world data and real information has been fed into these models. Now what the client is saying that, okay, we're done with the whole simulation work now. And now we want to bring this into the real world, get into the physical world. And now when you get these items into the physical world, now comes the part of procurement. Now comes the part where you have to identify who is the manufacturer of these pipes, who's making these ducts, what are the sizes of these ducts, and how are they going to be fabricated. Like this is the fabrication shop that you see here in this picture. And what's happening here is that we have modeled all this way in the most, let's say, in a cost effective and time saving manner, and the client is approved of all this, and all this is going to be installed exactly in this same fashion, same arrangement. Now what we can do here is that, how it used to be earlier was that all this material would be procured in bulk, it would be brought to the site, and it would be just laying there in bulk, in possibly, let's say, it can either be kept in a safe or an unsafe manner, all this material lying around the construction site. And you would be buying a lot of bulk material, but you will only be using a certain amount of it for that particular time, because you wouldn't be installing all the pipes in one day. You would be having, let's say, a particular zone that you're working on a particular day. Now what this allows us, modularization, what it allows us to do is that we can have the entire routing and the whole pipe routing broken out into certain small segments, much like how you break a jigsaw puzzle. And then what you do with the jigsaw puzzle is you just place those pieces together and you have the whole picture in front of you eventually. Now this is what modularization is. What it does is that I get one module of this ducts, and I just fabricate these inside the fabrication shop, and I'll just have to take this module as it is to the construction site and install it directly. And all of this has been done, it's approved by the client, it's cost effective and saving on the whole time aspect as well. So this information now, when it's being brought out in the real world, we'll have to ensure that we feed in the right amount of information. We have to feed in information like the manufacturer, and we'll be having to feed in any information which would be helpful to the person who is buying all these items in the real world, who will be the client who's in the US, who will be buying all these things from the suppliers. He would have to get in touch with them, and he would have to give them the information that we have provided inside the model. On that basis, all these things are procured, and then they're assembled together, and then they are directly put together on site. Now, one benefit of this is that the sites are not so noisy. The construction sites are not going to be noisy at all. You won't be having anybody welding the pipes, so you wouldn't be having anybody cutting those pipes, and you won't be having so many cutting material and machines laying around here and there. So a lot of time will be saved and space is saved on site, and all this is done in the fabrication shop itself, and then it's just transported in a truck and assembled on site. So this is one element of BIM, and this is really time saving, and it's a lot more easier to assemble very complex areas. Like this is a pretty complex area to assemble. If you break the pipes and ducts away and you first install the ducts and then install the pipes, so it becomes pretty difficult and time taking for the guys on site to put these things together. But what if I just set up like a jigsaw piece and just easily and directly attach these things together on site, like breaking up large chunks of these services and putting them together on site. So that becomes easier to do. Now we have the conflict detection and resolution. So this point has been discussed in the earlier slides as well. And this is just an example of how, in the simulation, you could see that this pipe is running through the ducts, and this clash, as what we refer it to, is identified, and then you get in touch with both the parties, with the people who are handling the pipes and the team that's responsible for the ducts. And then you come across a solution that, okay, I'm going to move my pipe downwards, or I'm going to route it in a certain way that we don't conflict or clash with this ducts again. So it says that problems identified early on in the virtual model and are not missed only to be discovered later on site. So these things can be identified inside the model itself, in the simulation itself, and if they would not have been attended to in the simulation, they will definitely show up on site. So you'll be having people reworking all this particular zone, and this would really impact the time schedule. And it would also, rework would definitely, it would cost you money. So the BIM softwares that we usually use are it's Revit and Navisworks. Then we have Autodesk Fabrication, and we have certain other add-ons from Autodesk, like BIM 360 that we're working with. So all these softwares are enabling us to work or get inside the simulated environment which the other stakeholders have created or we are working on. I mean, we have people who are working in the United States, we have people working in the Middle East. So together they're working in one common environment. And to get to that, inside that environment, we'll be requiring certain softwares and enablers on our side as well. So that is possible through the softwares that some of them have been listed here. So summary of this presentation, well, mostly I would say it's people, process, and technology. The whole concept, the procedures, the standards, it all revolves around the people aspect. You know, the technology exists to serve the people well. The processes exist to serve the customer well. And together, these elements in collaboration work to achieve the common goal of the client. So as I said in the very beginning, that we build things twice, you know, and that models are a database. You know, everything is built in a simulation in the real world. It's tested, real information is being fed in, and exactly those things will be reflected on site. And no conflicts would then occur in this, among the site personnel, and everything is done in a more standardized, and it's being done within the time schedule. And you know, we have minimized any chances of rework or, you know, any areas where money could be overspent here. So begin with the end in mind is what I would say here, that you must have the picture clear about what the customer eventually needs, and on the basis of that, we would be putting in the information in our simulation board. So this is just one quote that I would like to end this presentation with, that technology and people will always be hand in hand. So, you know, technology won't replace people, but people who use technology will probably replace people who do not. So to work well with in the changing world, you'll have to adapt yourself to the technology that runs the modern world. So we'll have to pick up on the skills that enable us to achieve the targets of today, and we have to pick up the skills that would make us more adaptable and agile when you're working on a project.
Sir, meanwhile, like Ashish sir has a question, so he's just putting up his question. Meanwhile, I just wanted to know, like BIM is a software, so what is the compatibility level for the CSEC students who wish to, like, is there any scope of other branches also taking up this thing?
We do have, as I said earlier, that, you know, new frontiers are coming up in the world of BIM, and we have virtual reality and augmented reality, which is now
Yeah.
serving us in these objectives.
Mm-hmm.
That, you know, earlier it was just a computer that a guy would walk around the model inside the model for, and now it is through AR and VR. You know, you could just have this whole model review done if you just put on a VR set, and you could literally walk inside a model which is
Okay.
scaled up to its right dimensions. So mainly for the CS and EC students, I would say these trades that we work with mostly revolve around the mechanical or electrical or the civil, civil engineering backgrounds. But as far as the AR and VR and certain, you know, the enabling part is concerned, so
Right.
definitely there is a lot of coding in Python that goes in the background.
Okay.
You know, a lot of scripts are run in the background. I mean, definitely, you know, these softwares are evolving, you know, we get a new software version of Revit every year. So, and every year we get some new benefits, new features that come across to the users. So these add-ins or these things are, you know, they're prepared by the R&D department of these software making companies like Autodesk. So definitely a lot of Python coding goes in the background here. And it's not just Python here, there are some other codes as well that are involved here.
Okay. Sir, we have a question from Divya Bishnoi, sir. He's a faculty at that college. And he's saying that it was a wonderful presentation, first of all. And he's asking that, does BIM really improve collaboration?
I would say yes, because we have a lot of platforms, or, you know, you could call those BIM softwares that allow us to communicate with the clients in multiple ways. You know, one way is let's say, okay, we can have a meeting and I can do some screen sharing and I can tell him, okay, this is one issue, that is one issue, and you work together. But there are also some softwares that, you know, you can have one issue and it's labeled inside the the model, the simulated model, and I can just leave it there. And the another person, when he works into his shift time and he can just check those items, they would appear on the top of his list. So now he knows that I am working and he knows what I'm working on. And along with that, we even have uh, communicating communicating interfaces like simple chat boxes visible in the BIM 360 interface that we use. We use, BIM 360 also allows us to, it takes up the role of Google Drive for file sharing and media sharing. So any issues that I can come across, I can just have those posted to BIM 360, and the person who's seeing this sitting at the other end of the world, he can just see those in in the live manner. He can see those things pop up on his screen. Okay, these issues have been identified by Vinayak. Okay, and these are his instructions, or this is his input of what he sees.
Okay. So one question from my side, Pinnacle visits our campus for the placements, and it's a regular recruiter. And so, like, if we wish to prepare our students for BIM, what are the specific softwares on which we should train them? Like, there are a lot of suggestions which come up. There is Revit, and there might be other softwares also. So, which is the best thing on which we can train the students to get acquainted to the BIM?
Well, the major softwares that we work with are there's a software called Revit by Autodesk, and we are also using AutoCAD here to prepare the drawings. And AutoCAD is something that's uh, everybody's familiar with since the third year, I guess. So Revit is one software that we are working with on it almost on a daily basis. And then we have Fabrication, which is a sort of an add-on interface which works collaboratively with AutoCAD and Revit. So Fabrication is what allows us to really get familiar with the real world data. And it's like a palette where you're building something inside a building, but the palette is comprised of all real items that are actually sold in the market. So these are the softwares that we use.
All right, sir. So we have another question. Mr. Devendra Bhatt is asking that is it possible to wow our client using 3D visualization? I guess wow means to impress our clients using 3D visualization.
3D visualization, well, the first thing that it does for you is that it, things are less reliant on your mind's imagination. It's really actually brought out in the computer world. So, it's like comparing a game called Contra with Counter Strike. So you have a two-dimensional game, and then you have Counter Strike, but it's a three-dimensional game, and you see everything in the three-dimensional world, and everything is certainly more detailed. And you have it's not just the 3D visualization that, as I said earlier, it's also things like manufacturer information, the cost of items, and facility management. And today we are working on one of the projects where we have it's an airport in the Middle East, where the airport has been completed, and it's in running condition. It's one of the busiest airports, and now what we're working on is that sometimes when you're executing something and by chance you have these issues where something does not get exactly built as per the computer simulation. So the site engineers do some on the spot decisions, and then they install things on site. Now what the team is doing here is that they have taken into consideration all those last moment changes and decisions taken by those engineers, and they have incorporated those into their model. Now what you have with you is an airport model that is exactly the same as the one that exists in the real world, out there where it is in the Middle East. And it contains exactly the same information. It has the same information of as the fan coil unit. It has the same information of the pumps that have been placed in the mechanical rooms. And you have information like manufacturers and service due dates and everything, and service duration. So, it's not just 3D visualization that can wow a client, but a client really gets, you meet the customer's requirements with 3D visualization, but, to really delight the customer, you provide in all these, you go these extra steps and you add in these information that for which, the customer feels that this is going to help me in the long run. It's not just going to help me in a model just to walk through the model, but it's going to help me when I really want to maintain this particular service or particular property. When I have to work on the maintenance, or when I have to call in someone for repair costs for repairing, I can know who to call, and I can get the information basically from the model itself, since it's an exact reflection of the real world. So on these deliverables that we provide, the client is satisfied.
All right. Thank you, sir. And one more question. Harshit Lohar is asking that please tell about which skill is required for being a BIM manager.
I started off in Pinnacle in April 2017. So as today, I'm working as a project manager, and so it started off with you start off as a BIM modeler. You pick up one service and you work on that particular service. You simulate those services and in the Revit model, and you work with other teams who are handling other services, and together you get, as you work and as you progress through your career, you get to realize about the other important things that run a project. You as you progress through your career, not just in this company or anywhere, any industry, you begin to get glimpses of the bigger picture. And I would say, yeah, there are definitely some certain skills, like you would be requiring the certain technical skills, you would be requiring the an idea of how a project is run and executed, the entire process flow for a project. But that basically comes with as you progress through your career, since as a trainee engineer, and you progress through, you become a senior engineer and then become a project manager, and so it really depends, I would say.
All right, sir. Thank you so much. I guess we have answered all the questions. And once again, thanks a lot for sparing out time for our students and giving such a detailed and nice presentation, and absolutely required and a good introduction regarding BIM. So thanks a lot on behalf of Poornima Group of Colleges, sir. And
Thank
thanks
you
on
so much.
behalf of our students also. Thank you so much, sir.
Okay, thank you so much for giving me the opportunity.